and coming out of COVID, I think it's just almost not surprising in some ways. But the format that if you've been here before and you come again next year in May, physically this is going to look a lot different. Keynotes will be in a separate part of the convention center, and the exhibit floor will grow even further. And this year we have 4 theaters. My guess is we'll have 5 or 6 theaters, so there'll be a lot of activity beyond the exhibits that are there. So in any case, just a little heads up for the future. It's my pleasure to introduce your speaker this morning. The title is a Big Data Platform. Mr. Doug Steinbaum, lead engineer, Big Data Platform, or BPD, at the Defense Information Systems Agency. In his role, he leads the migration of both Big Data Platform and its DevOps environment on-premise to cloud environments. Previously, he oversaw the development of the BDP baseline and integration with DISA Analytics. So he's been along the ride here as this has matured. What is BDP? It's a common distributed computing solution capable of ingesting, processing, sharing, and visualizing multiple petabytes of data from DoD information network sources. He's going to tell you a lot more than I can. Let's give him a warm welcome.
Good morning, everyone. I'm Doug Steinbaum. I work with the Defense Information Systems Agency in the Cyber Analytics section, and I will be giving an overview of what the BDP is and some of the capabilities and benefits it has, the value proposition, as well as going into a little bit of the technology under the hood, how it works, why we made some of the technical decisions we made, and also discussing some areas where we're hoping we can get some input and help from industry in terms of improving the current state of affairs with the product. Disclaimer. All right, so as was initially stated, the BDP is a common distributed computing solution that allows the ingest and storage and analysis, visualization, and sharing of multiple petabytes of data that can come in from disparate sensors of pretty much any type that can be parsed using custom parsers and visualized in the system. The system is a software distribution. It's not an appliance or a product of that nature, so it can be basically deployed and scaled up or down as per the needs of the customer. It can basically allow the balancing of the need for compute and performance against the cost. And it can also be deployed either in an on-site environment, on-premise, or it can be deployed in a cloud environment to take advantage of the scalability and performance and cost benefits of the cloud environment. As shown in the diagram here, the system is somewhat modular and hierarchical. So the platform is layered on the bottom there, and then on top, the third-party analytics can be deployed. And this system has the ability for analytics developed to a somewhat proprietary but nonetheless standardized interface, set of APIs, so that the analytics are somewhat portable and can be shared across BDPs used by different mission partners. As I mentioned, it can ingest data from various types of IA tools. It can be used for other types of tools as well, but we use it for IA C&D, so it's used for that purpose. We have a number of different mission partners that are using the system as shown in the diagram. There's the Defense Information Systems Agency, as well as the Army, the Air Force, Marines, and U.S. Cyber Command also using the system. As shown there, the systems are all integrated into some type of a constellation or web, and this allows the users on one system to actually query and access data on another system, so that basically the data can be ingested and stored near where it's generated, and users can take advantage of that data regardless of which system they're hosted at their local site. And this system has a number of different use cases that are fairly popular with it. The main one is obviously to operate and secure the DoDIN. Some of the use cases are for such as situational awareness. Basically, the system allows to get a good idea of the security posture of the networks. that are ingesting data from. And it also allows to do incident response. It has functionality designed to help do functionality similar to that of a SIM. So you can do incident handling, you can do ticketing, you can do team analysis and teamwork in there. And it also allows one to gain insight about the activity of the hackers on the network and about the types of techniques, tactics, and procedures that they may be using against your network by correlation against indicators of compromise and indicators of attack. All right. I just want to make one other comment regarding the system. One of the unique capabilities is it does have a data translation function, so that even though various mission partners may be ingesting the data in a native format, it can actually pull it out and convert the format so that it's more familiar and can be correlated against the data at the other local sites. Okay, as shown here, and I'll go into a little bit more in the future slides, but there are a couple areas where we're trying to get industry assistance. The first and foremost is in the terms of analytics. We want to take things to the next level in terms of our analytics. We're currently not using a whole lot in the way of artificial intelligence and machine learning, and as a result, we are having to throw more and more personnel at the system to solve the problems, and that's not feasible. And so we need to find ways to improve the effectiveness of analytics using these new technologies. So some ideas about different types of libraries and algorithms would be very beneficial. Another area we're looking for input from the industry is in terms of analytic notebook capabilities. The primary way of getting analytics onto the system right now is to develop custom software for the system, and that takes a while to do. It has to be developed, debugged, accredited, and deployed on the system, and that's inefficient. There is an alternative method using analytics notebooks such as Zeppelin or Jupyter on the system, but there are some issues with that in terms of limiting the ability of the users to access data to which they don't have permissions or access to certain parts of the system. So we're looking for some suggestions in that area. And finally, we're also looking for newer platform technology that will help us better scale up to larger amounts of data and better handle federated data. We're currently using a database system in here called Accumulo, which has been around for a while. It's very efficient, very fast, but it does have a couple drawbacks, which we'll go into a little bit later on. All right, right now I just want to touch on where things are with the project. DISA was responsible for developing the BDP project platform environment for the past 7 years or so, and we were the ones who were basically taking the requirements from the mission partners and rolling them into the system. But back in February, the leadership of DISA basically made a decision. They wanted to transition this baseline ownership over to the unified platform team, as they had better financial resources to support the project, and we felt that that would better help the system be more successful and beneficial to the users. So as of then, the platform as well as the DevSecOps environment was transitioned over. Nonetheless, DISA does still remain an active participant in the community, and we are still actively coming up with new ideas to implement into the system, which is why we're here today, trying to get some help with some of those ideas that we've been working on. We also have a couple of these deployed ourselves, and we are continuing to sustain those and make sure that they are integrated with the other systems in the constellation as shown in the previous diagram, the distributed query capability. We're still continuing to maintain that as well. And last but not least, we do maintain the DevSecOps environment, which is used for the analytics developers as well as for the platform developers to collaborate and develop. All right, so I'll go over, this is a little bit of an eye chart. I won't promise too much into the details here. But basically, this is a representation of a notional diagram of the various components of the big data platform and how they're interconnected. And so I'll basically explain what we try to accomplish with this and some of the challenges that we've encountered based on some of our technology decisions and where we're looking for help on that. and hopefully that will facilitate follow-on discussions with industry. So basically, at the top there, you can see that's where the analysts come into the system. They interact directly with various applications on the system. The applications are either bundled with the system, as in the case there's a Unity interface which does a lot of correlation and search, query, visualization type functions, and then there's an interface from which users can pick and choose and launch third-party applications that have been uploaded to the system. And basically, the apps are ways of encoding more complex queries and more complex functions that can't be done in just a simple Boolean search. And that's where it leverages these particular applications. They leverage the various libraries which we have down in the lower right, which are predominantly the Spark library. And there's also an older MapReduce library, which is less popular now because it's not as easy to use. We also have an R-Shiny library, and there's also the Kibana interface, which works with our Elastic Stack. As shown in the colorful part of the diagram, there's a number of different APIs which are designed to help facilitate the openness of the platform so that industry can and other partners can develop analytics to run on the system. And these interfaces are RESTful interfaces, use the Swagger IO API, which is self-documenting, so it facilitates that. And basically any kind of access to the system, whether it's querying or getting state or other types of operations, are accessible in there. Below that, we have the various databases represented here in the middle. The primary database that we have in there is called the Accumulo database, and that's a wide column database based on the Google Bigtable and database. And it's very fast, very efficient, but it does have a number of issues with it. It was originally picked because it does the cell level security, which provides very good granularity security, and we take advantage of that by having role-based access control so that the users have various roles and various visibilities that they can use to control what data they can actually get to. And that's very helpful because we have a federated environment, and we want to make sure that not everybody can see everybody else's data unless they want them to be able to see each other's data. Nonetheless, the Accumulo has a couple of drawbacks. First and foremost, one of its big issues is it works off the Hadoop file system and uses some of the other Hadoop components. And the file system, of course, is good in that it's very reliable, but the drawback is there's a lot of overhead. It basically requires, with the current version we have, everything to be stored basically 3 times for redundancy. And when you're talking about petabytes worth of data, that becomes very expensive very quickly if you're using a cloud, or basically becomes impossible when you're using an on-site environment, which is what we're currently doing as we migrate over to the cloud. So that's a big problem. I know there are newer versions of Hadoop out there that have less redundancy, but nonetheless, we're hoping there may be some other alternative types of database that have the similar types of security functions as Accumulo that won't take up as much space for storing the data. Another issue with the Accumulo type database is that it basically does not work well in terms of aging off of data. What I mean by that is because we're ingesting large amounts of data, there comes a point when we have to start throwing some of that away or putting that into cold storage. And what we found is that at least the way the BDP and the Accumulo system are designed, once the data is aged off, it has to be re-ingested if one wants to look at it again. And that's a very expensive computationally process to do. And that also, we have found, at least with our on-premise system, it gets to the point where we can't even ingest new data because the system is so bogged down trying to pull in the old data. Also, another issue that is specific to the Accumulo platform is that it does not allow us to actually age off data on a per data type basis. So basically, if you're pulling in data from a firewall and from an intrusion detection system and from some other type of system, some of those data sources are very verbose, they take up a lot of room, and they may not be as useful long term. And so the analysts basically have told us that they want to keep some types of data around for maybe 6 months, sometimes for a year, some for a couple of years. And Accumulo doesn't really allow us to do that. Basically, with Accumulo, you have to get rid of everything that's older than a certain date or not. You can't just say, I'm going to get rid of all of the data from sensor A that's older than a certain date, unless you go and do a query and find all those data records and then delete them by one. So those are areas where we're hoping we can get some insights from industry on maybe how they've used Accumulo or some other types of databases that they may have used that can perform these kind of functions a little bit better. Another database we have on the system here is Elasticsearch. We're currently using the ELK stack in there for a couple of purposes, one of which is for caching purposes. It's used basically so that basically when the data comes in, you get a couple weeks worth that are in the Elastic cache, and then if you want to do a quick query, it'll do an immediate search on that. Elastic is very good because it allows us to do autocomplete and full text search, and you can basically look for something the moment it's actually popped into the system, which is very nice. Whereas with Accumulo, it takes a little bit longer before you can actually process it. So that's for basically helps use the system in more of a real-time manner. Although different use cases are, may or may not use it in a real-time manner, but that's what that purpose is. And then there's also, as you can see there's a Postgres database, which is basically just used for some minor back-end types of functions and so forth. So those are the main components there that I think I wanted to go over. And as I mentioned, the analytics libraries there as well. Not shown there, of course, is the lower level components. This system runs on Linux and on Hadoop. All right. Next up, I want to go a little bit over our DevSecOps environment, which we call DevForce. This is an environment that's been used for a number of years to facilitate the collaboration of the analytics developers and the platform developers. This has been very critical because one of the issues we've had and found here is that when one updates the platform, the analytics tend to break, and that's been a big problem actually, because we tend not to use the analytics notebook type approach, and so even though we have APIs on there, due to the level of the coupling of the components, it actually does break. So we're trying to find better ways to address that issue. But with this DevForce, and we're kind of getting out of this business because this is transitioning over to Cyber Command unified platform. But we're actually hosting this now until the end of the year, fiscal year, so until they get their new system up and running. But basically, this is just your standard DevSecOps environment. You have a knowledge base here, so anyone who's interested in actually developing for the BDP platform, we actually do have API documentation and information on all the analytics, how they work and how you can interface with them, as well as the system on the left side. And we also have a standard DevSecOps component in the center there for actually building and compiling the code, and then a request tracking system basically where the mission partners can input their requirements, and we can basically pull them out and develop them. All right. So basically just wanted to kind of wrap up here. So as I did mention, we are looking for feedback, even though we are no longer in charge, so to speak, of the baseline. We are an active partner in developing the capabilities and facilitating the integration of new functionality into the BDP. And one of our areas of focus is the analytics development area, so we really are hoping to find some ideas on how we can better take things to the next level with AI and ML. We are looking for advice on industry inputs and discussions on how we can better accommodate federated data and larger scale data with a type of database that can handle better, do better in terms of aging off, and do better in terms of re-ingesting of the information and not requiring so much redundancy in how the data is stored. We also, although not mentioned here, we're really trying to find a way we can better take advantage of cloud native technologies. This product was originally developed about a decade ago, and was not developed at the time. There was cloud was very commonplace, and so the way it works now is it actually uses direct attached storage. For example, it doesn't take advantage of, like, in a typical cloud environment, you have the compute and the storage are separate. This doesn't really take advantage of that, and as such, you can't scale the two up and down independently, and so that's a big drawback. So, anyways. Do appreciate your time. Just wanted to put that out there and stimulate some follow-on discussions if we could. All right, that's all I had. If there are any questions or comments, I can take them.
Good morning. What's the BDP's current and potential future role with Joint Cyberspace Command and Control, JCC2?
Sorry, with the JCC2, you're saying?
Yes, BDP's current and future role with JCC2.
Okay, I think you referred to some of the analytics that if I know what you're talking about. I believe there are certain analytics that were going to be ported onto that, and my understanding is that is actually occurring, but that's kind of out of my wheelhouse, but that's what I've heard.
Okay, thank you.
You're welcome. Any other questions? Yeah, just come up to me afterwards. I'll give you my contact information.
So, not so much a question, but just an appeal to industry here. I think it's fair to say that BDP has been neglected for a long time. It's the best of technology from the last decade, and we're looking for a different way to do this. It's perceived in operational circles as ineffective right now, and you can see a number of additional data analysis tools that are in use because of that. And so if you guys have ideas for how to do that better, we're all ears. Thanks.
All right. Okay. Thank you very much. Hi. Fine. Thanks.